Hi students, once again I welcome you all to my channel Abrar Sir classes. Today we will be seeing some important problems on the chapter rotational motion. This is part 5 of the video. This is the first problem. The moment of inertia of a uniform thin rod of length L and mass m about an axis passing through a point at a distance L by 3 from one of its ends and perpendicular to the rod is, okay, this is a thin rod. Okay, they have given what? A rod of mass m and length L. Okay, now we know that this is what its centroidal axis. Okay, this is passing through the center of mass, ICOM, and we know very clearly how much is ICOM. ICOM is 1 by 12 ml square. 1 by 12 ml square. We have seen in the previous videos also. Okay, this is a rod. Okay, 1 by 12 ml square. Now they are saying an axis passing through a point at a distance L by 3 from one of its ends. Okay, now another axis, okay, which is passing through what? This is the axis. Okay, now this is the axis of rotation. Okay, this axis of rotation. This is what? ICOM. This is what? Axis of rotation. They have considered. Okay, at a distance of what? L by 3 from one of its ends. This is L by 3. This is L by 3. Okay, this is see point A to B. Let us say point A to B. Okay, this is B and this is A. This is C here, center. Okay. A to C is how much? This is L by 2. And C to B is how much? L by 2. Then how much this will be? This will be L by 2 minus L by 3. That is L by 6. This will be L by 6. Now I can use what? To find I, moment of inertia, I can use what? Parallel axis theorem. I is equal to what? ICOM plus of m, that is mass of the thin rod, okay, m into this distance, the whole square, that is L by 6 the whole square. Right, okay. Now ICOM is how much? 1 by 12 ml square plus m L square by 36 after squaring. So 36 I can take what? LCM. How many times? 3 times 3 ml square plus of 36, 36 one time, 1 into ml square, that is equal to 4 ml square by 36, that is equal to 1 by 9. 1 by 9 ml square is the right answer. I is equal to how much? Okay, 1 by 9 ml square is the right answer. Hope you have understood this. 1 by 9 ml square. Let us see the next problem. It is saying two rings have their moments of inertia in the ratio 2:1. What they have given? They have given two rings have their moments of inertia. That is I1 by I2 is equal to how much they have given? 2 by 1. And their diameters are in the ratio. Okay, diameters are in the ratio how much? 2 by 1. Okay, the ratio of their masses. Okay, their m1 is to m2 is equal to how much? Okay, we know that for a ring, what is moment of inertia? I can write this as m1 r1 square, mr square we know. Okay, m1 r1 square divided by m2 r2 square. The same can be written as what? m1 by m2 into r1 by r2 square. Okay, now they have given d1 by d2 is equal to 1. What is r1 by r2 is nothing but what? d1 by 2 divided by d2 by 2, because the radius is what? Half of diameter. Okay, 2 gets cancelled. That is same as what? d1 by d2. That is same as what? 2 by 1 itself here. Okay, now what is I1 by I2? That is 2 by 1 is equal to m1 by m2. We do not know. Okay, we have to write how much is r1 by r2. That is 2 by 1 the whole square. Right, that is equal to 2 by 1 is equal to m1 by m2 is equal to 4 by 1. Okay, this gets cancelled 2 times. That is equal to m1 by m2 will be equal to how much? 1 by 2. This comes in. That is equal to m1 is to m2 is equal to 1 is to 2 is the right answer. Hope you have understood this one. 1 is to 2 is the right answer. Let us see the next problem. What is saying? 4 thin rods of same mass m, okay, and length small l, okay, form a square as shown in the figure. Moment of inertia of this system about an axis through center O, okay, and perpendicular to its plane. Okay. Now you are supposed to calculate the moment of inertia. Okay, this axis. Okay, assume that this is coming out of the plane of the board or going into the plane of the board. Okay, this is how much distance. This is L means how much this is. This will be how much? L by 2. L by 2. Hope you understood. Okay. What is the value of I here? I come in nothing but 1 by 12 ml square. ml square. Hope you understood this. Okay. Now, same here also L by 2, L by 2, L by 2. Okay. So, moment of inertia, we are supposed to calculate. Okay. I will be equal to, that is equal to, I is equal to, okay, you are supposed to calculate the amount of inertia of axis through IO, okay, you are supposed to calculate IO is equal to, see, this, that is ICOM, this is ICOM. How much is ICOM? We know that ICOM is equal to what? 1 by 12 ml square. Okay, this is, everything is, I is equal to what? ICOM, okay, that is equal to ICOM, okay, plus of, what is the mass? M into distance the whole square. How much is the distance? L by 2 the whole square. And like this, for how many rods? For how many thin rods? 4 thin rods. I have to multiply it by 4. Okay. Therefore, I naught is equal to 4 into ICOM is how much? 1 by 12 here. 1 by 12. Okay. 1 by 12 M L square, small l. Okay, we'll write small l the whole square, right? Plus of m l square by 4. By using what? By using parallel axis theorem. Okay, by using what? Parallel axis theorem. 4 into what? ICOM plus m, product of, this is mass and perpendicular distance. Okay, m l by 2 whole square, m l square by 4. Now 4, I can take 12 as m l square plus of 3m that is equal to 1/4 of 3 4 by 3 4 by 3 m l square is the right final. Hope you understood this very easy, but do not forget to multiply this 4. Okay, this is assume that it is coming out of the plane of the board or going into the plane of the board. ICOM will be equal to, at the center, ICOM is 1 by 12 ml square for a thin rod of mass m and length L. Okay, now how many rods are there? 4 rods are there like this. Okay, here also okay. L by 2, L by 2. Therefore, 4 by 3 ml square is the right answer. Hope you understood this is the right answer. Next problem, we'll see what is this. 2 spheres of mass m, okay, each of mass m, okay, this is mass m, they are given here, and radius r by 2 are connected with a massless rod. This is the massless rod. Okay, this is a massless rod of length 2r as shown in the figure. What will be the unit of inertia of the system about an axis passing through the center of one of the spheres and perpendicular to the rod? This, okay, they are supposed to calculate it. Okay. What is I y y dash let me call this as sphere P, and I y dash will be equal to what? Moment of inertia of sphere P about y dash. Understood? Moment of inertia of sphere P about y dash plus moment of inertia of sphere Q about y dash. Okay? I y dash not to calculate. Two spheres are there. What is moment of inertia of sphere P about y dash? That is equal to how much is I come here? I come will be equal to how much? For a sphere, how much is I come? That is equal to 2 by 5 m r square. Okay, for a sphere you have to remember this one. Okay, 2 by 5 m r square. Okay, moment of inertia of sphere about P about y dash is equal to, okay, this one. Okay, how much is this? 2 by 5 m r square, that is equal to 2 by 5 m. In place of r they have given, be careful, r is what? R by 2 the whole square they have given. Okay, that is r by 2 the whole square. Understood? In place of 2 by 5 m r square, you have to write r by 2 the whole square. M r by 2 the whole square plus of how much is the mass? Mass m. And how much is this distance? This distance is 2r the whole square. 2r the whole square. Hope you understood this. Okay, 2 by 5 mr square. But here, how much? 2 by 5 m. In place of r, you have to write what? R by 2 the whole square. R by 2 the whole square. This I am writing here. Okay. In general, what is I come? For a sphere of radius r, that is 2 by 5 m r square. But radius is given is how much? R by 2. We have to write what? R by 2 the whole square. Hope you understood this one. Okay. Now what is moment of inertia of sphere Q about y dash? That is equal to same. Okay, that is 2 by 5 m. In place of r square, you have to write r by 2 the whole square. Now add up these two. This, okay, 3 terms you have to add up. These 2 terms plus this one term. You will get the answer. I y dash is equal to 2 by 5 m r square by 4 plus m 4 r square plus 2 by 5 m r square by 4. I can write this 2 times, that is 2 into 2 by 4 to 5 4s are 20, right? Okay, m r square plus of 4 m r square, that is equal to 1 by 5 m r square plus of 4 m r square. Again take I as LCM. I can write m r square plus of 20 m r square. That is I y dash will be equal to 21 m r square by 5. 21 by 5 m r square. This is the right answer. Hope you understood this. Okay, you have to be careful here. Okay, this is in general write 2 by 5 m r square, but here r is what? R is what? R by 2 the whole square. Okay, that you have to be careful. And here, while calculating moment of inertia of sphere P about y dash, you have to be careful here. You have to add up this one. Okay, m into perpendicular distance between this axis and this axis, that is 2r. I hope you understood this one. Next problem is the moment of inertia of a disk of mass m and radius r. This is a disk, okay, kept in the horizontal plane. This is a disk. Okay. Now we know that for a disk, this is a disk. Okay, this is a disk. You can take CD. Okay, CD, compact disk. Okay, ICOM. ICOM is how much for a disk? Disk of mass m and radius r. That is equal to 1 by 2 mr square. 1 by 2 mr square. Now what is it? The moment of inertia of a disk of mass m and radius r about a tangent to its rim in its plane. In its plane. Okay. Yesterday we discussed in the previous video. Okay. Now if I write a tangent here, okay, this tangent is what? This tangent is perpendicular to plane. That is what we call IT. What about this one? What about this one? This is IT dash. Okay, this is what? Tangent lying in the plane, lying in its own plane. Okay, that's you are asking. How much is IT dash? You are asking. How much is IT dash? You are asking. That is nothing but what? Now you can write a diametrical axis. Okay, you can write a what? Diametrical axis. Okay, this is, I will call this is what? Diametrical axis. What is moment of inertia? Let me call this as I dash com. That is equal to half of I com. How much is I com? I com is 1 by 2. Half means 1 by 4 mr square. 1 by 2. Now IT dash will be equal to what? Now you use what? Parallel axis theorem. I can write IT dash is equal to what? I dash com. I will write here. IT dash is equal to what? I dash com plus of m into what is the perpendicular distance? Perpendicular distance is r only. This perpendicular is r only. M r the whole square. How much is I dash com? Just now we calculate I dash com is equal to 1 by 4 mr square plus of mr square. Now we add up these two, get the answer. Okay. 4 is LCM mr square plus of 4 mr square, that is equal to 5 by 4 mr square. 5 by 4 mr square is the right answer. Students, hope you have enjoyed these problems. Kindly share it with your friends. Ask doubts in the comment box. Subscribe for my channel and like the video if you have really liked it. Thanks for watching this video. I wish you all the best for your KCET, NEET and IIT examinations.